What we're going to talk about today is material sequencing and part sequencing in Rite. So, oh, there's my ugly mug. We'll skip to that one, and Andrew covered that, and there I am again. So here we go. Let's define Rite a little bit. I'm assuming most of you are users, and if you're not, forgive me, we'll come back, or I can come back and cover some of this other information. But we know that the Rite is a saw optimizer, right? We'll create patterns and we'll send them to your saw, and it's also a nesting optimizer, right? We'll create patterns and machining, we'll send them to your router. We'll create reports, right? We'll tell you how much yield and how much waste, and we'll create reports for both of those. And we'll import your parts and your production list if you have the product module. Then finally, and ultimately, what we want to do with this tool is we're a production management tool, right? So we will grab your materials and we can sort it according to your standards. We can do the same with your parts and so much more. So we want to take you up from wherever you're at and get you to that next level. And hopefully some of the information I'm going to give you today will do that. Where we go? There we go. So here's what we're going to do, or at least try to do. We're going to cover some information out of the standard optimizer and its material sequencing. The professional optimizer, and it has material sequencing and part sequencing. And the nesting optimizer, it has material sequencing, part sequencing, and pattern sequencing. So here we go. In an ideal shop, what do we want? We want the parts to flow in some sort of orderly fashion from our saw or our router to the machining center, if you have one, your edge bander, your horizontal boring machine, and assembly. That would be ideal, right? But what happens oftentimes? We get this, right? Everything gets scattered. We get parts everywhere. We get stacks of material everywhere. We end up turning around and having to reprocess stuff because we've lost track of what's going on. Oftentimes it's because we've pushed too much material or too many parts through the saw or through the router. Many times I've had conversations with shop owners or production managers who've had pallets of parts or a pallet of parts stuck in a corner because nobody knew what they were, and they got remade. It was faster to remake than to do that hunt, right? Or the Easter egg hunt, as it's been called. So what we want to do is explore this material and the part sequencing to see if we can't get rid of some of that and get back to that more ideal situation where the parts and the materials flow in some kind of logical sequential order for us and for you. So the first thing we'll look at is the material sequencing. And the way we set this up is the same whether you have the standard, the professional, or the nesting optimizers. And if you have Rite open, or if you're looking at it, or if you want to look at it later, take a screenshot of this. This is your system parameters in version 11. Down at the bottom of the boards tab, you've got this board order and automatically created list. We've got that 3 deep ladder logic that you can take advantage of. If you hit the drop down, you're going to find all the cells from your board library, whether it's your material name, your board code, your cost, your length, width, whatever it is. You can use that to sequence your materials and how they're going to arrive at your saw, the order they're going to arrive at your saw or your router. So I've got shops out there that use this in a couple different ways. They might do it just based on the thickness. They want all their thickest materials ran first, or they might want their most expensive materials to go first, or the materials that require the most intensive processing to go through first. And by intensive processing, I mean parts that are going to go to the machining center, and then the then the edge bander, and then the horizontal boring machine first, and then parts that don't require quite so much are going to, or materials that don't require quite so much are going to come through second. And the way I set that up isn't so much through the material name, but I use this box here, this information box. And if I trained any of you, you probably heard me at some point say something along the lines of, that information box, it's not used for anything. And for 20 years, it probably wasn't, or more. But now we can, just by dropping in like a 001 or a 002 or 003, and let that be our sort. And you can have more than one material use that 001 or that 002 or an AA or whatever kind of naming sequence you want to use, and let that control your order. And so that's what I like. And we can use that for your processing to keep everything in order. And it does a couple things. One, not only does it help you post saw or post router, you can use that for the material handler as well. So when he gets that list of material and he knows what order it's got to hit that saw, makes it easy for them to pull an order and put the materials back in order. So when he gets the next order, it's easy enough for him to, oh, well, every time I'm pulling these first, I can put these back in order. So there's not quite so much disruption in the warehouse as it were. And finally, what I like is that we can change this order if we use the information cell in the board library on the fly. So if you're looking out the shop and you see that the edge bander is jammed up, or if we see the drawer assembly area is jammed up and we've got this information set up as our criteria, as our priority, we can change a 01 to a 04 very quickly, or reverse this order, optimize it, send it down, and help back off the load off of that area in the shop. Might hurt the material handler guy a little bit, but that's okay because now we've kind of improved what's happening post saw or post router a little bit. All right. So if you have any questions on that, please submit them to Andrew and we'll get to them at the end, but hopefully that's fairly straightforward. This is important, it does not affect your optimization or your yield. Okay. So now we're going to move to part sequencing. And you do need, for optimizing purposes, you do need the Pro Optimizer, and you need either that or the nesting, depending on what you're doing. Oops, jumped ahead, sorry about that. In the Pro Optimizer parameters, you need to be looking at the Rules tab, and you'd be down at the bottom at the priority or the box for priority parameter. If you hit that drop down, what you're going to find is your information box. Information boxes rather, and you can pick or create any one of those that you want to use for your priority. I've got customers out there that use, as it's listed here, their cabinet numbers. If they're merging their jobs together, they use work order numbers. They'll use purchase order numbers. They'll use groups of cabinet numbers by using a cutting list rule. So they'll look at the cabinet number and maybe cabinet 1 through 10 or 1 through 20 becomes their first priority. And cabinet 21 through 40, say, becomes priority 2. And they can start processing those cabinets in an order. So ideally, as they're flowing through the shop, they stay together, and B, they're hitting assembly at roughly the same time. And you can break that number down as fine as you want and make life a little easier for your guy at the saw because he's not sorting as much. He's just looking at that priority number and keeping those groups together. It's going through the machining center and the edge bander and the horizontal boring machine together, but it's also hitting assembly together, so they're not breaking apart so many kits and making their life harder, or sorting so many kits. We have this strict priority option right here. So if we check that, only the first priority gets cut on that saw at a time. So it will hurt your yield a little more to have that checked, but the guy at the saw is only cutting that first priority at any given time, and that's it. So the benefits for this, again, your parts flow is leaned out a lot. We're going through one priority at a time, and we're not sorting as often. I was in a shop last year. They were cutting or producing, according to them, about 2,500 cabinets a week at the time, and they were sorting their cabinets no less than 4 times before they hit assembly. We were working on that. We're still working on that to get that process cleaned up, but they were wasting hundreds of man hours a month doing their sorts. It was killing them, and they're getting better. It is definitely a work in progress, but it's something that they saw the benefit to. Their process engineer and I were going through it, and they're getting there. So something to take a look at that. Nesting. So if you're using a router, this can definitely pay off for you. If you look at your nesting parameters and look on the nesting 3 tab, Down towards the bottom, you have your priority again, and this is your priority information box. Again, comes right out of your information boxes. We've got 4 priorities, 5 if you choose none or count none. And I'm going to go through each one of these real quick. The first one here is the one that's really the quickest to work with, because it's kind of the most wide open after a fashion, and the easiest to understand. Your first priority gets cut, and as there's room, we bring in the next priority. We move to the next sheet. First priority, once it's complete, we just start bringing in the next priority again, and then we draw basically an invisible line, and we move on to the second priority. So in the order on the part list. Priority 2 is the strict priority. So kind of the version of the professional optimizer, where we set that strict priority on. Priority 1, but we're not going to do any number 2s until all of the 1s are complete. And then we'll move on to number 2s. Priority 3 is a little different in that it looks like the strict priority, but we're not going to introduce the number 2s until the 1s are completed. And then we'll do the 2s. And the same as we're working down into our deeper priorities. The information box priorities. These 1s and 2s are kind of throwing me a little bit today. Priority 4 is a little bit more flexible. It's kind of a combination of all 3 of them, or at least 1 and 3 rather, and that we'll do the 1s and 2s together, right? And we'll move on to 1s and 2s here. But now, even though there's still 2s available here, we're going to start reaching deeper into our priorities, into what's available to make the most of the yield. Because we want to make the yield better for you. We still want to keep that sort for you, make it as easy as possible, and help the guys out in the shop and keep those carts limited as much as possible, and just make life easier. If you're labeling, whether it's off the saw or whether it's off the router, we can put that priority number on that label nice and big. So if you're blind like me, that big number is very, very helpful, but it'll make it easier, right? So boom, we got priority 1, priority 2, priority 3, priority 4. When we're out of 1 and all we're doing is 2s and 3s at this point, we know we're done. And we can pass it along, get rid of that cart, and bring in the next empty cart. I took a very large job in nesting. I made it large on purpose so we can see some disparities here. So I took all 4 priorities plus the none, and I took over 30,000 parts. So it'd be nice to have a job this big, but I don't think I'll ever run one this big. And with no priority, I ended up just shy of 286 hours, all the way to the strictest priority of 286 hours and 28 minutes. And this is nothing but perimeter routing. There's no machining going on or anything like that. The difference in patterns, or boards rather, is only 29. So this took 3474, this took 3503. Where my time savings is coming in, when I'm looking at this from a production manager point of view or an owner's point of view, is that my sort time for my shop is going to be much, much lower. So when I'm looking at this, and the point on this is, with that large part list priority 2, my first 189 patterns were all priority 1. And there were a total of 9 priorities that we could have picked from, right, in that whole list. In the large part list priority none, the first pattern was 9s, 3s, 4s, and 1s. The second pattern had 1s, 3s, 5s, 7s, and 9s, and so on. So very quickly, I would have 9 different carts around that router. I would have people waiting for parts because I wasn't anywhere close to being done with anything. So there would be a bottleneck somewhere. There'd be jams. And again, I know it's a very big job, but again, I did that on purpose. My average minutes per sheet, not much, 3 seconds. So that wasn't going to hurt me. It's all sorting time. Finally, pattern sequencing. Again, in nesting parameters, again, we have 3 layers of logic. Most of the shops I deal with are looking at, they want to run the highest quantity of pattern first. And then if they do anything else after that, they're looking at board length. They run the shortest boards first and then work their way out to the longest. And that's generally because of the fly cut they have to run to clean up the spoil board. This does not affect your nesting. It does not affect your yield. So again, this is a kind of a recap, and this actually went faster than I thought it would. Standard optimizer can handle your material sequencing. Professional optimizer can handle the material and the part sequencing. Nesting optimizer can do your material, your part, and your pattern sequencing, with the full goal of get your consistent material flow from your warehouse all the way through to your machines. Get your parts produced in order, not randomly, right? Not based on whatever the part list has in it and what the material list says. Assembly is not flooded with unnecessary parts. Right? We get the cabinets completed as parts arrive as much as possible. There's a lot we can do to control that. Users, so the cut-right users are in control of the cabinet production. That's the goal. We want to keep that as tight as possible. And reduce your lost parts, right? And you add labeling into that. If you're not labeling yet, that makes it even better. And that sums it up. If you have any questions, I would love to hear them or see them in this case.
Hey, Rob, Andrew here. Hey,
Yes,
I was just wondering, while you have the floor, while you've got a cut-right interested audience,
Yes.
are there any topics or quick tips that you might have, especially in regards to what you've shared, or some often asked questions that you might want to just address right now?
Well, I do get a lot of questions or people looking for ways to lean out. And when I say lean out, they look for ways to keep cabinets together through the shop. And yes, there are definitely ways we can do that in addition to what we just went through. And it's tangential to this, where we break up the part lists and keep the cabinets together that way. So if we want to do a batch of, say, 5 cabinets together or 10 cabinets together, we can literally just cut the materials for those cabinets and then move on to the next 5 or 10 cabinets, whatever it is. So that is really beneficial to a lot of shops, because sometimes, again, we have those bottlenecks. And that's part of the goal with cut-right within that production management tool, is to even that flow out within the shop.
Right. No, that's excellent. Do you want to talk real quick? You're kind of one of our cut-right experts, and you conduct actually a lot of these virtual courses as well for Styles University. Do you want to talk real quick about what those courses are that you're often teaching?
Sure. I teach 3 routinely. One's on the standard optimizer, one is on the pro, and one's on the nesting. They're taught one-on-one when we do them live. So I don't have 4 companies sitting across the country and me trying to field all the questions. So they're very much custom tailored to each individual. We also teach classes on product building, if they have the product module. So I take a company all the way through, not just the basic modules, but how to build products within cut-right. So teach them how to build a wall cabinet or a base cabinet or drawer cabinets or whatever, and then how to get it out to their different machines.
We do have one question here from John Buell. John's wondering, what are some of the chief differences between cut-right 10 and cut-right 11?
John, that is like a 200-page list. And and I will be glad to get you a document on that. And I'll get your email address, or if you'll send it to Andrew, and we'll get you that document.
Perfect. So I just put Rob's information up on the screen.
Oh yeah, that's even better.
Yeah, he'll be happy to answer any questions that any of you have. He's, like I said, an expert when it comes to this, and a lot of information available to share. So if anybody has any other questions, please submit them quick. Otherwise, we're going to conclude this webinar. There was a couple questions around, will we be sharing a recording? We will. Take a look at that. Stay tuned to your email. We'll be sending out the recording. Also want to give a mention in regards to Styles University Online, our new online training platform. We have a series of courses available there where you can learn on demand, whether on your phone, computer, or wherever. These are available at your convenience, and more information is available on that at stylesuniversity.com/SUO. And I also want to mention that we are offering a free 7-day trial right now, and that information is again available at that website. I'm going to jump ahead so you got additional information there. So again, stylesuniversity.com. If you have any further questions about Solutions Live, this webinar series that we're doing, or would like to request a specific topic,